You may have been told that Newton invented the concept of mass we know today. But if you asked Newton himself, he would have been forced to give you a circular definition. This is because the father of classical physics made great contributions in the field without knowing what mass actually is. And in this video, I'm going to explain why, and most importantly, how he brilliantly navigated around it. When you read the Principia, Newton defined mass as quantity of matter, or in his own exact words,
the quantity of matter is the measure of the same, arising from its density and bulk conjunctly.
He also added,
it is this quantity that I mean hereafter, everywhere under the name of body or mass.
And on the surface, that seems to make sense, as in, mass is simply the quantity of matter an object consists of, right? Yes, that is not wrong, but it presented one fatal logical flaw. In this context, Newton defines mass in relation to density. What is density? Density is the mass per unit volume, meaning that Newton defined mass using density, which is also defined using mass. It's like a dog chasing its own tail. To make matters more interesting, while he was doing his math, he realized he was dealing with two behaviors of mass: inertial mass and gravitational mass. Inertial mass is the tendency of a body to resist acceleration. This is the mass which he elaborates in his first law of motion and the one that drives his second law. Then, gravitational mass is a tendency of a body to move towards another body, and this is the mass which causes objects to fall and orbit other bodies. He elaborates this in his universal law of gravitation. But here's the mystery. There is no inherent mathematical reason why an object's resistance to acceleration should perfectly match its gravitational pull. But when Newton did the math for falling objects, the masses cancelled out, proving they were equal. Hilariously, Newton had no idea why. In fact, he couldn't explain how gravity mechanically pulled these masses across empty space, which forced him to famously write hypothesis non fingo, I frame no hypothesis, which is a diplomatic way of saying, trust me bro, the math works. It was not until 230 years later that we get to know why these masses are equal, and this has got to do with gravity. Thanks to Albert Einstein, now we know that gravity isn't just a pulling force, but the bending of space-time. So, mass tells space-time how to curve, and space-time tells mass how to move. Inertial mass and gravitational mass are equal because they're simply two sides of the same coin. Now, does this explain where mass fundamentally comes from? Of course not. That involves quantum mechanics and the Higgs field, which is massive enough of a topic that it requires its own dedicated video, so subscribe to stay updated for that one. Because Newton couldn't explain what mass was, he stopped asking and focused on what mass does. He isolated inertial mass and applied it in his second law, leading us to the formula we know today as F is equal to ma. But this formula is misunderstood. Most people think it talks about force, but it doesn't. It actually defines the exact limits of Newton's understanding of matter. Click this video to find out.